this is a Sparx transition workbook for year 6 to year 7, and there's lots of key skills within this pack. We've got introduce, strengthen and deepen for each of the sections, and we're looking at place value, negative numbers and so on. These are all the key topics for year 7. You can download this pack from the link in the description, and then I'm going to go through each question with you to really prepare you for year 7.
Which one of these numbers has 4 tens? So let's think about our place value grid. We've got the thousands column, the hundreds column, the tens column and the ones column. And if we had any decimals, we'd put the decimal point here, and tenths and hundredths would go on the other side of that. So I've got 543, so that's 5 hundreds, 4 tens and 3 ones. I've got 534. I've got 435 and I've got 4,563. So that's where they'd go in the grid, and hopefully now you can see that we're just looking at the tens column. Which of those numbers has a 4 in the tens column? So which one has a 4 worth 40? And that's going to be 543, just that first number there. For the second question, write 406 in figures. So 406 is going to have a 4 in the hundreds column and a 6 in the ones column. And then because there's no mention of the tens, we know that there aren't any. So this is 406. For question number 3, write down these numbers in order of size, starting with the smallest. So I find it helpful to, again, put them in that grid. We've got point here, so this is going to be our ones and our tenths on this side. We've got the tens here, not that we've got any, but we've got 3.8, 3.6, 3.9, let's just make this longer, I'll rub it out in a minute, 3.5 and 3.4. So all of those numbers have a 3 in the ones column, so that's not going to help us compare. So now we're looking at the tenths column, and we can see we've got an 8, 6, 9, 5 and 4. So we can just write those in order from smallest to biggest. They all have the same importance because they're all in that tenths column. So we're going to start with 3.4 and then 3.5 and then 3.6 and then 3.8 and then finally 3.9. Let's just get that out of the way. There we go. In which two of these numbers does the digit 7 have a value of 0.7? So we're looking for a 7 in the tenths column. This has a 7 in the ones column, so that's no good. This one has a 7 in the tenths column, so that one's good, we want that. This one has a 7 in the hundredths column, so that's not the right column that we're looking for. This one's got a 7 in the tens column, a 7 in the ones and a 7 in the tenths column. So this one is also good. So our answer is 23.71. That has 7 tenths. And also 14.78. That also has 7 tenths. Page number 2. We're now on to strengthen. So same topic, but just a little bit more challenging. Which of these numbers show 5,008? So we're looking for a 5 in the thousands column and an 8 thousands, hundreds, tens and ones. We've got no hundreds, no tens and 8 ones. So 5,008 is that one there. This one is 50,008. This one's 508. This one's 500,008. And this one is 58. So 5,008 is that one there. Question number 2. Arrange these numbers in ascending order from smallest to largest. So again, I'm going to line these up on top of each other. 4.46. 9 is in the ones column. 8.8 is like that. We can put 9.0 if you find it helpful. 1.5. 6.06. 4.21. So notice that we've lined up those decimal points. These are all in the ones column. This is the tenths column. And this is the hundredths column. So firstly, we're going to look at the ones column. That's the most important. That column has the highest importance. So we've got a 4, 9 and 8, a 1, a 6 and a 4. So it doesn't matter what's after the decimal point. If the number is smaller in that column, then the rest of it doesn't matter. So we can see that 1.5 is going to be our smallest. And then we've got a 4 as the next smallest, but we've got this one and we've got this one. Now, out of those, to know which one's smaller, we need to look again at the next column over. And in the next column, we've got a 2 and a 4. So 4.21 is going to be the next smallest, and then 4.46, because we're using that next number to be able to tell. So we've used those. Now we can see the next smallest is 6.06, because we're looking at the next smallest in the ones column. And then we've got 8.8, and then we've got 9 or 9.0. Which of these numbers is closest to 1? So we can see that with all of these numbers, they've got a 0 in the ones column. So we have 0 ones. But we have a 9 in the tenths column. Now, all of them have a 9 in the tenths column. So we're looking to make this number as big as possible to get it as close to having one whole as possible. So the tenths column isn't helping us because they're all 9. Let's move over to the hundredths column. That's the next most important column. So we've got a 4, a 0, a 4, a 0, a 3 and a 4. Which of those is the highest? Well, it's the ones with a 4, and there are 3 of them. We've got this one in orange, this one in pink, and this one is purple. So between those, we need to check the next column again. And again, we've got a 0, we've got a 0 because there's nothing here, and we've got a 0. So again, that's not helping us. So we need to move over again, and we're looking at the 4, we're looking at a 0, and we're looking at the 8. So here, orange, this number is our biggest. They all had a 9 in the tenths column, so that wasn't helpful. The next column over, the hundredths column, the 4 was the biggest we saw, and then the 0 was the biggest we saw in the thousandths column, and then the 8 is the 10,000ths column, and that is the biggest number there. So 0.9408 is the closest to 1. That was quite tricky, that, so well done if you got that one. For question number 4, arrange the number cards in the place value grid to make the largest possible number. So we've been limited here to the ones, tenths and the hundredths column. So we're going to want to use the biggest number in the column that has the most value. In this case, that's going to be the ones column. So I'm going to put the 9 here because that makes the most difference. And then I'm going to use the 5 because that's going to have the next biggest impact. And then I'm going to use the 3. So 9.53 is going to make that as big as possible. Work out the number that should go in the box to complete the sum. So we're now on place value, but we're now on deepen. So these are the most challenging questions on place value. Work out the number that should go in the box. So we've got 8,000, add something, add 5 is 8,065. Now the 8,000 is there, the 5 is there, we've got no hundreds to worry about, but the 6 here, and it's in the tens column, so that tells us that we need 60 in order to make this question correct. For question number 2, write down the number 2,030,000 in figures. So let's use our grid again. We have the decimal point, and that has our ones column next to it, our tens column, our hundreds column, our thousands column, our 10,000s column, our 100,000 column, and then the million column goes next to that, so quite a long way over. Now we want to do 2,030,000, so we need a 2 in the millions column, and we need 30, so that's going to be a 3 in the tens column. And then all of the columns that don't have any numbers in, we need to put zeros to hold their place value and keep that decimal point where it needs to be. So zeros in here, so we're left with 2,030,000. And we tend to put a comma every 3 columns over just to help read it a little bit clearer, but it's not essential at all. Using these cards, what is the closest number to 320 that you can make? You must use all the cards and use each card only once. So let's do our grid. We've got 320 is our target. So hundreds, tens, ones, and then we've got the decimal point here, and then we've got tenths on this side. We've got to use a point, so we know that that has to go there. Now we want to make 320, so let's use the 3 in the hundreds column, and let's use the 2 in the tens column, and then we're pretty close. We've used the 2 and we've used the 3. We've now got a 5 and we've got a 7. Which of those is going to get us closer to 320? we want to use the smallest possible number here. So we're going to put 5 in the ones column. And now that we've used that up, we're going to have to put the 7 over here. But that's still better than doing 327.5. We want to get as close as possible to 320. So our answer is 325.7. And we've used up all of the numbers on the cards that they gave us. Question number 4, arrange all 3 number cards below to create the largest even 3-digit number. So if our number is even, it has to end in a 2, 4, 6, 8 or 0 in the ones column. So let's do hundreds, tens and ones. Now this number here in the ones column has to be one of these. It has to be even. So that means we can only use the 8. So let's put that there. And then they've told us they want it to be the largest even 3-digit number. So of the numbers that are left, we want to make it as big as possible. We've got a 5 and a 7. So to make this number as big as possible, we're going to put the 7 in the hundreds column, because that's the place value. That's the column that's going to make the most difference. And then the 5 will have to go in the tens column. So 758. That's it on place value. So going back to the top, and your contents page, we've done all 3 of these. So introduce, strengthen, deepen. It's okay if you just manage to do introduce, or if you manage to do all 3, that's absolutely great. And we're going to move on to negative numbers next. Negative numbers, introduce. What numbers should replace A, B, C and D on the number line? So when we're thinking about negative numbers, it's all the numbers to the left of 0. So we've got a number line here, and it's going to go up in ones. We can see because it goes 3 to 4, 4 to 5, so we can see that it's going up in ones. So if I'm starting on 0, 0, C would be 1 and D would be 2. Going the other way, we go -1, -2, -3, -4, -5. So A would be -4 and B would be -2. We go up in ones this way and down in ones this way, and that just fills out our number line. Question number 2 says, what number is the arrow pointing to on this scale? So let's fill it in. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. So we're going from 0 down to -10. Each jump is going to be worth 1. So it goes -1, -2, -3, -4, -5, -6, -7, -8, -9. So the arrow is pointing to -8. Question number 3. The weather map shows the temperature recorded one night last winter. Which city had the lowest temperature? So we've got lots of different cities here. Let's plot them on a number line so we can see which one is the lowest. Edinburgh is 3 degrees, so that's in our positive numbers, that's there. York is -2. Cardiff is -4, that's down here. London is 4 up here. Exeter is 10 and Dublin is -6. So the lowest temperature is going to be the one that is the furthest into our negative numbers, and that's going to be -6. Which city is that? Well, that's Dublin. So that is our lowest temperature. For question number 4, which is higher, -4 or 1? Well, again, we know that negative numbers are always lower than positive numbers. -4 is here and 1 is here, so 1 is going to be higher. For question 2, which is higher, -6 or -2? And because both of these numbers are negative, we want to go as close to 0 to get the highest number. So let's rub this out and just show you. -6 is going to be down here, 1 lower than -5. And -2 is going to be here. So which is higher? -2, because it's further to the right. So that's our answer there, 1 and -2. To strengthen now, find the temperature that is 9 degrees lower than 4. So if you're at 4 on the number line, and we want to go 9 degrees lower, we're saying we want to go 9 to the left. We're going to take away 9. It would take us 4 to get to 0. And we've got 5 more to go, so we're going to go down and we would land at -5. If that's confusing, we can just count down. So 4, 3, 2, 1, 0, -1, -2, -3, -4, -5. And that would be 9 lower. So -5 degrees would be my temperature there. Write these temperatures in order, starting with the coldest. So again, we just want to think about a number line here. Which of these numbers would be furthest to the left? Here's my 0, positive numbers this way and negative numbers this way. So we've got 9, minus 8, 3, minus 10, 0, 7. So minus 10 is going to be the lowest. Then moving up, minus 8 would be my next lowest. Then moving up again, we've got no more negative numbers left. So 0 is going to be my next smallest. Then I've got 3. Then I've got 7. And then I've got 9. So sorry, I should have done them all as degrees C. Degrees C, degrees C, degrees C, degrees C, degrees C. There we go. So there we go. That's in order. Negative numbers are the smallest, moving up to the bigger positive numbers. Question number 3, write these numbers in ascending order. So ascending means going up, lowest to highest. So the smallest here is going to be minus 770. That's way into the negative numbers. Then my only other negative is minus 17, so that comes next. Then I'm into the positive numbers. 7's the smallest of the positive numbers. Then 70, then 77, and then 700. And you're essentially just thinking about your number line and working from left to right. Okay, we're going to use these inequality symbols. So we're going to write less than or greater than in the empty boxes to make the statements correct. So you might have learnt at primary school that the crocodile eats the bigger number. So sometimes we draw little teeth on like this. Sorry, that's terrible drawing, but you get the point. Sometimes we draw teeth on and we can say the crocodile eats the bigger number. But I think it's easier just to remember that the bigger number goes at the bigger end. So this number, this end is bigger and this end is smaller. So we put the bigger number at the bigger end. So for 3 and minus 7, which one of those is bigger? Well, we know that positive numbers are always going to be bigger than negative numbers. So we're going to put it that way round to show that the 3 is bigger and the minus 7 is smaller. For the next one, we know that minus 2 is bigger than minus 8 because minus 8 is way further down on the number line into the negative numbers. So that's going to go that way round as well, with the minus 2 at the bigger end and minus 8 at the smaller end. And with the next one, minus 6 is smaller than minus 4. So we're going to go that way round to show that minus 4 is bigger because it's at the bigger end of the inequalities. So we would read that as 3 is greater than minus 7, minus 2 is greater than minus 8, and minus 6 is less than minus 4. Question number 5, write down these numbers in ascending order again. So ascending order means lowest to highest. The smallest then is going to be the most into the negative, and that is minus 4.5. A bigger number with a negative is going to go more into the negative and therefore be the smallest. So minus 4.5. Then we've got, should have crossed it out, sorry, minus 4.2. And then we've got minus 2.5. That's all our, oh no, sorry, I lied. Then we've got minus 2. And that's all our negative numbers. So that's the smallest negative number up to the biggest negative number. And now we can look at the positive numbers. And we've got 2.1 and we've got 4.3. So that's going from smallest to biggest. Okay, so now we're into the deepen section. So these are the most challenging questions on negative numbers in this pack. Put the number cards shown below in the gaps to make the lowest possible number. Use each card once. So we've got this negative here for us. So that's telling us that we're working in negative numbers. Now, if we want the lowest possible number, think about your number line. You've got 0 here, your positive numbers to the right, your negative numbers to the left. We want to go as far this way as we can. We want to go the most negative we possibly can because that's going to get us the lowest number possible. To do that, we want to use this 8 in the thousands column here to say, yeah, we want to go as much as possible down to the left. So 8,653 because we're making this number as big as possible so that we go as much into the negative as possible, and that makes it the lowest possible number. For question number 2, put the number cards shown below in the gaps to make the lowest number possible, so same. So we're going to go as much into the negative as we can. The decimal point should have numbers on both sides, and each card should be used only once. So we want to make this number, this part, as big as possible, so that when we make it negative, it goes as much into the negative as possible. Now to do that, I want it to have the decimal point as far over to the right as possible. So I want to have as much of the number to the left of a decimal point as I can. Now I can't, we were told in the question, I can't put it here because I've got to have numbers on both sides. So then the decimal point is going to need to go there. And that's going to allow us to make the biggest possible number, which will then make it as small as possible. So we're going to do 800. Again, we're prioritising those big numbers in the furthest over columns. And then 73.2. So we've just made the big numbers at the start to make it as small as possible overall when we make it negative. Well done. So question number 3, using each of the cards below only once, what is the closest number to minus 64.28 that you can make? Okay, we haven't got a 6, so we can't put a 6 here, so we're going to have to think around that. So 64.28, it would be 64 is closer to the 50s than it is the 70s. So let's go for 59. That's going to get us as close as we can. 59 point... And then again, we want to make this as big as possible because we're trying to get up to 64.28. So 0.73. It's going to be our answer there. We could have gone for 70 something, but because 64 is closer to 60, we want to go down. We could have gone 73. That would have been good, but 73 would have been further away than 59. So well done if you got 59.73. Question number 4, Ethan is thinking of a negative number that is lower than minus 4 and higher than minus 10. His number is odd and a multiple of 3. What number is he thinking of? So let's just sketch out our number line again. We've got 0 here, minus 4 about here, and minus 10 maybe somewhere down there. So we're looking for numbers in between minus 4 and minus 10. We also want it to be odd, which means it's going to end in a 1, 3, 5, 7, 9, or in this case just be 1, 3, 5, 7, 9. And we're looking for it to be a multiple of 3, so it needs to be in the 3 times table. 3, 6, 9, 12, 15, 18, and so on. So between minus 4 and minus 10, let's check. We've got minus 5. That would be no good. It is odd, but it isn't in the 3 times table. Minus 6 is not odd. Minus 7 is not a multiple of 3. Minus 8 is not either. Minus 9. Now, minus 9 is good. So minus 9 would work. It's an odd number and it's also in the 3 times table. It's between minus 4 and minus 10, so minus 9 is our answer there. Okay, we're now on to rounding. So we're introducing rounding here. These are the easiest questions of this topic. What is 63 rounded to the nearest 10? So when we round, we're rounding to the nearest 10. We look at the tens column and we always check the next column over. The next column over is the ones column in this case, and it's a 3. Now 5 and above, we round up, and 4 and below, we round down. So 63, the 3 tells us to round down, so that rounds to 60. Think about your number line. We've got 60, we've got 70, 63 is about here, and we're saying, what's the nearest 10 or multiple of 10? So we can see that that rounds down to 60 because it's a lot further to round up to 70. But just checking that next number, that's all we need to do. So question number 2, what is 720 rounded to the nearest 100? So 7 is the number in our hundreds column. Always check the next column over. And in this case, that's a 2. We know that 2 rounds down, so this is going to be 700. For question number 3, round 350 to the nearest 100. 3 is our hundreds column. Check the next number. The next number is 5 in the tens column. We know that rounds up. So 350 is going to round up to 400. Question number 4, what is 12.5 rounded to the nearest whole number? So if we're rounding to the nearest whole number, we're rounding to the nearest ones. So we're going to check the next column over, which is the tenths column, and we can see that there's a 5, which rounds up. So 12.5 is going to round up to 13. That's the whole number above. What is 5.47 rounded to the nearest whole number? So again, we're checking the tenths column because we want just to know what the nearest 1 is. Check the tenths column and it's a 4. So that needs to round down. So 5 is our nearest whole number. Question number 1. So we're on strengthen now, slightly more challenging. Rounding to the nearest 10, which 2 numbers round to 40? So 46 would round up to 50 because the 6 tells us to round up. 33 would round down to 30. All I'm doing is I'm checking the ones column. If it's 5 and above, it will round up, and if it's 4 and below, it will round down. So 41 would round to 40 because the 1 would round down. 39 would also round to 40 because the 9 would round up, and 48 would round up to 50. So we've got 41 and 39. There are two numbers that would round to 40. Question number 2. A pair of jeans cost £21.62. What is the cost of the jeans to the nearest £1? So we're looking to the nearest 1. This is our ones column. This is our tens column. And we're going to check the next column over, which is the tenths column. In the tenths column here, we can see we've got a 6, and we know that a 6 rounds up. So that's going to be £22. Question number 3. What is 5,279 rounded to the nearest 100? So if we're rounding to the nearest hundreds column, there's our hundreds column, we check the next column over, which is a 7. 7 we know rounds up. So that's going to be 5,300. Notice it doesn't have any effect on the 5 because that's to the left of the column we're interested in. Question number 4. When rounded to the nearest 1,000, which two of these numbers round to 8,000? So here we're rounding to the nearest 1,000. This is our thousands column. We're going to check the hundreds column. This is our thousands. We're going to check the hundreds column. This is our thousands. We're going to check the hundreds column, and so on. So this one is going to round to 7,000 because the 4 tells us to round down. This 5 tells us to round up, so that's 9,000. This 3 tells us to round down, so 8,000. This 5 tells us to round up, so 8,000. This 2 tells us to round down, so 7,000. This 7 tells us to round up, so 9,000. So then, to the nearest 1,000, which two of them rounded to 8,000? It would be that one and that one. So 8,312 and 7,528. And last question on this page, what is 990 rounded to the nearest 100? So this is our hundreds column. The next column over is the tens column, and we can see it's a 9, so it needs to round up. Now what happens when we round a 9 up is that it needs to become a 10, but we don't have room for that, so we're going to need to spill the 1 over into the thousands column. So 990 actually rounds up to, let's put a 0, and then we need this to be a 10, but that's no good, is it? So we'll put a 0 there, and we'll put the 1 in the thousands column. So that is actually 1,000. Well done if you got that one, it's quite tricky. A school raises £1,876. The local newspaper writes that they raised 1,900. Complete the sentence shown below. The newspaper has rounded to the nearest what? So we can see that if we rounded to the nearest 10, we would check the ones column and 6 rounds up, so it'd be 1,880. So that's no good. Let's check the next column over. So if we rounded to the nearest 100, we would check the tens column, and we can see that that's a 7. 7 rounds up, so it'd be 1,900. So here they've rounded to the nearest 100. So we're going to put 100 in there. Wonderful. Question number 2. Tim thinks of a whole number. Rounded to the nearest 10, his number is 20. List all the possible numbers Tim could be thinking of. So thinking of numbers below 20, let's put 20 here on a number line. Thinking of the numbers below 20, if we go as low as 14, that would be no good because that would be closer to 10. But 15, the 5 would tell us to round up. So we've got 15, 16, 17, 18, 19, 20 would round to 20 as well, wouldn't it? 21, 22, 23, 24. Now when we get up to 25, we know that the 5 would mean we would round up to 30. So we're going to stop at 24, and those are all our numbers that round to 20. All our integers anyway, all our whole numbers. Question number 3. A piece of string is 14 centimetres long to the nearest centimetre. What is the smallest possible length of the piece of string? So let's think of examples. It's been rounded to the nearest centimetre. So it didn't get rounded to 13. That would have been a centimetre down. So it could have got rounded to 13, but it didn't. So we know that it was something like 13.7. That would be a good one. That would round to 14, wouldn't it? We could also go lower. We could go 13.6. That would be okay. And what about 13.5? Yeah, that would be the lowest we can go. If we go any lower than that, 13.48 or 13.4 anything, it would round down to 13. So we want to go as small as possible, but still ensure that there's a 5 in the tenths column, so it would round up to 14. So 13.5 is the lowest we could go. Question number 4. The number of people in a stadium is 47,000 when rounded to the nearest 1,000 people. What is the minimum number of people that could be in the stadium? So again, we want to think lower, so we want to go 46,000. And how big can we make this where it still rounds to 47,000? 46,000, we want to go 500. All the numbers bigger than that, up to 47,000, would round to 47,000. But 46,500, if I go any lower, 46,499, the 4 would tell us to round down. So we're going to stick with 46,500. And that's the smallest we can go, but still round up to 47,000, a 5 in the hundreds column. Well done if you got those, they were quite tricky, and we're moving on to adding. Complete the calculation to work out 145 add 352. So when we're adding, it's really important to line up the columns, and they've done that for us. So we've got the ones over the ones, the tens over the tens, and the hundreds over the hundreds. 5 add 2 is 7, 4 add 5 is 9, and 1 add 3 is 4. So our answer is 497. For the next one, we've got decimals. 16.3 add 25.2, and again, everything's lined up. So we've got the ones here, the tens here, and this is the tenths column. And we've got our decimal points lined up too. That's really important for adding or subtracting. 3 add 2 is 5. 6 add 5 is 11. So when we get a number bigger than, so 10 or bigger, we put the ones here and then carry over the tens. So 6 add 5 is 11. So we've put 1 and carried the 1 there. 1 add 2 is 3. Add that extra 1 is 4. And we need to line up that decimal point. So that is 41.5. Question number 3. Use the prices below to work out the total cost of 2 erasers and 1 pencil. So eraser is 20p. Sorry, that answer should be over here, shouldn't it? Answer. So we've got 2 erasers, so 20p and another 20p. And we want 1 pencil, which is 25p. And we're going to add those all together. 0 add 5 is 5. And 2 add 2 add 2 is 6. So that is 65p. Question number 4. What is the total cost of a tube of toothpaste and a toothbrush? So we're going to add these together, and we're going to make sure we line up those decimal points. And put a line underneath and say we're adding. 5 add 0 is 5. We're always starting at the right hand side. 8 add 3 is 11. So 1, carry the 1. 1 add 3 is 4. Add that extra 1 is 5. So it is £5.15. Add together 1,750 and 281. So this number and this number are different lengths. So we want to make sure that we've lined them up in the right column. We want to put the 200 underneath the 700, 80 underneath the 50 and 1 there. So then we've got the same numbers in the right columns. 0 add 1 is 1. 5 add 8 is 13. So 3, carry the 1. 7 add 2 is 9, add the extra 1 is 10, so 0 carry the 1, and 1 add 1 is 2, so 2,031. Okay, now we're moving on to strengthen, so a little bit more challenging. We've got 135, add 17, add 133. Adding those together, again, we're going to start at the right-hand side. 5 add 7 is 12, add 3 is 15, so 5, carry the 1. 3 add 1 add 3 is 7, add that extra 1 is 8, and then 1 add 1 is 2. So we've got 285 there. Question number 2, work out 18.2, add 34.1, notice I'm lining up the decimal points here, add 13.5. So 2 add 1 add 5 is 8, 8 add 4 add 3 is 15, carry the 1, 1 add 3 add 1 is 5, add the 1 is 6, so you've got 65.8 there. Question number 3, 15.6, add 8.76, so that 8 is a ones, so it needs to go underneath the 5.76, and again put a line underneath that, and we're going to add them. Now you might find it helpful here to fill in any gaps with zeros. and then we can see what we're doing. 0 add 6 is 6. 6 add 7 is 13, so we're going to put 3, carry the 1. 5 add 8 is 13, add the 1 is 14, so 4, carry the 1. And 1 add 1 is 2, and we've got that decimal point there, so 24.36. Question number 4, 17,468, add 2,606. So again, we're just lining up those columns. 8 add 6 is 14, so 4 carry the 1. 6 add 0, add the 1 is 7. 4 add 6 is 10, so 0 carry the 1. 7 add 2 is 9, add the 1 is 10, so 0 carry the 1. And then we've got a 2, so that's 20,074. Moving on to deepen, fill in the gaps below to complete the calculation. So we've got a grid here and we know that something add 9 needs to make 2. Well, how can that be? Well, we can see here that it's actually been a 12 and we've carried the 1. So that needs to be 3. 3 add 9 would make 12 and then we can carry the 1. 2, add something, add this extra 1 down here, now needs to make 8. So we can see that 2 add 5 would make 7, and then the extra 1 would bring it up to 8. So we're going to turn this box here into a 5. So 2 add 5 is 7, add the 1 is 8. There we go. And then 6 add 1, this would be 7. And we can just double check that answer to check we're happy with it. 9 add 3 is 12, carry the 1. 2 add 5 is 7, add the 1 is 8. And 6 add 1 is 7. Yeah, so that works and we're really happy with that as our answer. Always good to check what you've done. Question number 2. In 1 week, a pilot flew from Paris to Sydney. Always going here. From Sydney to Mauritius. From Mauritius to New York. And then back to Paris from New York. How many miles did he fly in total? So we're doing 10,532. Add 5,642. Add 9,273. Add 3,625. Now, there's nothing wrong with breaking this down. You might want to just add 2 of them together, add the other 2 together, and then add those 2 answers. Nothing wrong with that. I'm just going to do it all in one big thing. So 2, add 3, add 5 is 4, 5, 6, 7, 12. So 2, carry the 1. 3, add 4, add 7, add 2, add 1. So that's 14, 15, 16, 17. 7, carry the 1. 5, add 6, add 2, add 6 is 12, 14, 20. Carry the 2. And 0, add 5, add 9, add 3, add 2 is 19. 9. Carry the 1. And then we've just got 1 at the top and the 1 down there. So that's 2. So 29,072. Question number 3, add together the 4 numbers below. So we've got 27.49, 38, which would line up there, and we can put 0.00, 9.78, and 6.8. And again, we can put some zeros in there. 9 add 8 is 17, carry the 1. 4 add 7, add 8, add 1 is 20. 7 add 8 is 15, add the 9 is 24, add the 6 is 30, add the 2 is 32, and 2 add 3 is 8. So that is 82.07. And that's addition. So most important thing to remember is to line up your decimal points and make sure the columns are lined up. Complete the calculation below to work out 847 minus 215. So again, we're lining up those columns. 7 take away 5 is 2. 4 take away 1 is 3, and 8 take away 2 is 6. So that one is 632. For question number 2, work out 3,784 minus 313. Again, we're going to lay that out, and we're going to line up the columns. So minus 313. 4 take away 3 is 1. 8 take away 1 is 7. 7 take away 3 is 4. And 3 take away nothing is 3. So we're left with 3,471. For question number 3, work out 646 minus 271. 6 take away 1 is 5. Now 4 take away 7 is harder for us to do. And if there's more on the floor, So the bottom number is bigger. We need to borrow from next door. So more on the floor, borrow from next door. And that's just when we're subtracting. So 4 take away 7, we're going to need to borrow from here. We're going to turn this into a 5. So we've borrowed 1 and make the 4 into 14. So more on the floor, borrow from next door. 14 take away 7 is 7. And 5 take away 2 is 3. So 375. For question number 4, work out 35.6 minus 12.5. And notice again, I'm lining up those decimal points, lining up the columns. 6 take away 5 is 1, 5 take away 2 is 3, and 3 take away 1 is 2. So 23.1. For question number 5, we've got 56.4 minus 13.7. We've got more on the floor, so we're going to borrow from next door. So 6 becomes a 5. And 4 becomes 14. 14 take 7 is 7. Line up those decimals. 5 take away 3 is 2. And 5 take away 1 is 4. So 42.7. Question number 1. Rob has £154. He spends £82 on a new coat. How much money does Rob have left? So we're going to start with the £154. And we're going to take away 82. And again, we're lining up those columns. 4 take away 2 is 2. 5 take away 8, well, we've got more on the floor, so let's borrow from next door. There's nothing left there, and 5 becomes 15. 15 take away 8 is 7, and then we have 0, take away 0, which is just 0. So our answer is £72. Tyler went to the shop with £8.30. He spent £4.60. How much did he come home with? So £8.30. Take away £4.60. 0 take away 0, that's fine, that's still 0. 3 take away 6, we've got more on the floor, so let's borrow from next door. 13 take 6 is 7. Line up those decimals. And 7 take away 4 is 3. So we've got £3.70. Subtract 1,549 from 1,637. So I'm going to put 1,637 and we're taking away 1,549 from that. So again, lining up those columns. 7 take away 9, we've got more on the floor, so let's borrow from next door. So that's 2. 17 take 9 is 8. 2 take away 4, we've still got more on the floor, so we're going to borrow from next door. 6 becomes 5, and this is now 12. 12 take away 4 is 8. 5 take away 5 is 0, and 1 take away 1 is 0. So we've just got 88 as our answer there. Subtract 3.5 from 13.3. 13.3, take away 3.5. More on the floor, borrow from next door, so that's 13 take 5, which is 8. 2 take 3, again we've got more on the floor, so let's take that 1, make it 12, take away 3, which is 9, and keep that point lined up, so 9.8. And then we have 2,361.4, take away 84.9. So I've lined up those tens, lined up those ones, and lined up the tenths and the decimal point. 4 take away 9, more on the floor, borrow from next door, so 14 take 9 is 5. 0 take 4, again we need to borrow, so that's 10. Take away 4 is 6. 5 take away 8, again we're going to need to borrow, so 15 take 8 is 7. And then I've got 2 take away 0, which is 2, and 2 take away 0, which is 2. 2,276.5. Moving on to deepen, so these are the most challenging questions of subtraction. Add 238 to 567 and then subtract 132. So we're going to do 2, 3, 8, add 5, 6, 7 first. That's 15, carry the 1. 3 add 6 is 9, add the 1 is 10. 2 add 5 is 7, add the 1 is 8. So then I've got 805 and then we're going to take away 132. 5 take 2 is 3. 0 take 3, I've got more on the floor, so let's borrow from next door. 10 take 3 is 7, and 7 take 1 is 6, 673. Question number 2. Grace is 1.45 metres tall. Jackson is 0.2 metres shorter, so that's smaller, so we're going to take that away. 1.45, take away 0.2. Now, really important that we're lining up those decimal points, and I'm going to put a 0 in here just so we can see we're doing 5 take away 0, which is 5. 4 take away 2, which is 2, and putting that decimal point there, 1 take away 0 is 1, so 1.25 metres. Question number 3, fill in the gap below to complete the calculation. 8 take away 3 is 5, so we're happy with that. 5 take away something is 8. Now, that doesn't seem right. So I think what they've done here is they've borrowed from next door. So 7, if we turn it into a 6 and make this 15, 15 take away something to make 8, it must be a 7. And then we've got 6 take away 5, and that does make 1. So that works out, that's nice. We could always check our answer by doing 185 add 573. 5 add 3 is 8, 8 add 7 is 15, carry the 1, and 1 add 5 add 1 is 7. So we end up getting that 758 that we had to begin with, so that's perfect, that works well. Jack has 14.4 metres of rope, Amy cuts off 2.68. How much rope is Jack left with? So we've got 14.4 and we're subtracting 2.68. Now we need something to subtract from here, so I'm going to fill in a 0. 0 take 8 has more on the floor, so we're going to borrow from next door. That becomes 10. 10 take 8 is 2. 3 take 6, again we need to borrow. So that's 7. 13 take away 6 is 7. 3 take 2 is 1, and 1 take 0 is 1. So 11.72 metres of rope. Great. Moving on to multiplying. So when we're multiplying by 10, we're going to move all of the digits one column to the left. So if we just think about 720, that's got a hundreds column, tens column, ones column. So we have 720 like that. And when we times by 10, everything moves one column to the left. If we were going to times by 100, it would move 2 columns to the left. If we were going to divide by 10, we'd move 1 column to the right, and so on. So because we're doing 720 times by 10, the 7 is going to move over to the thousands column, the 2 is going to move over to the hundreds column, and the 0 is going to move over to the tens column. But we need to put a placeholder in to make sure that these numbers stay in that column even when we haven't got the grid. So we're going to put another 0 in there. So it is 7,200. So work out 56 times 100. Similar method. I'm just going to extend this down so we've got it up here. So 56 is currently here. If I times it by 100, I want to move it 2 places to the left. So the 5 is going to end up in the thousands column, the 6 is going to end up in the hundreds column, and then we need to just hold the place value with 2 zeros, so 5,600. Work out 17 times 3. So to do 17 times 3, I'm going to lay it out like this. It's less important about lining up in these ones, but we'll come on to that. 3 times 7 is 21. So put the 1 here and carry the 2. 3 times 1 is 3, add the 2 is 5. So we've got 51. So I've just done the 3 with the 7 and then the 3 with the 1, like that. So 26 times 7. 7 times 6 is 42. So 7 times 6, 42, 2 there, carry the 4. And 7 times 2 is 14, add that 4 is 18. So 182. Same method here. 284 times by 5. 5 times 4 is 20. So 0, carry the 2. 5 times 8 is 40. Add the 2 is 42. So 2, carry the 4. And then 5 times 2 is 10. Add the 4 is 14. So we've got 1,420. Okay, multiplication again, but strengthen now. Use the multiplication table below to calculate 22 times 14. So we're going to go to 22, and we're going to go to 14, and we're going to go down, and we're going to go across, and then we can see that that answer is 308. Work out 36 times 21. So to do this, 36 times 21, 1 times 6 is 6, 1 times 3 is 3. So we've dealt with the 1 times 6 and 1 times 3. Now we're going to move over to this 2, but it's not really a 2, it's actually a 20. So I'm going to put a 0 here so that when we treat it like a 2, it's actually going to be treated like a 20 because of putting that 0 in there. 2 times 6 is 12, so 2, carry the 1, and 2 times 3 is 6, add that 1 is 7, adding that up is 6, 3 add 2 is 5, and we've just got a 7 here. That 1 was from before, so we can cross that out if we like. 756. If you struggle with that method and you would like a different method, so if you've not got a good grasp of how to do this, there is another method, and that's drawing a box, and we're going to draw it too wide and too tall because there's 2 numbers here and 2 numbers here. And we're going to put 36 along the top times by 21 down the side. Every box needs to be split diagonally, like that, from the top right corner to the bottom left, and then we just make it a little bit longer. And then all we're going to do is the number at the top times the number at the side. So 6 times 2 is 12. 6 times 1, to go down here, is 6. So we're going to put 0, 6. 3 times 2 is 6. So we're going to put 0, 6. And 3 times 1 is 3. So we're going to put 0, 3. And then all you need to do is add down the diagonal columns. So in this first diagonal column, you've just got 6. In the next diagonal column, you've got 2, add 0, add 3, so that's 5. And in this last diagonal column, you've got 6, add 1, so that's 7. This just makes 0, so that's fine. 756. So that's another method. If you got to the end of year 6 and you weren't confident with this method, feel free to have a go at this one, because it's secondary school. That's absolutely fine. Work out 17 times 503. So I'm going to switch this round. 503 times 17, like that. 7 times 3 is 21, and 7 times 0 is 0. Add the 2 is 2. 7 times, so we've done 7 times 3, 7 times 0, now we're doing 7 times 5, which is 35. And then we're done with the 7, so we're going to move over to the 1 here. And instead of a 1, it's actually a 10, so we'll put that 0 in. 1 times 3 is 3, 1 times 0 is 0, and 1 times 5 is 5. Adding that up is 1. 2 add 3 is 5, 5 add 0 is 5, and 3 add 5 is 8, So 8,551. Doing it the other way, we've got 503, which is 3 boxes wide, times by 17. Split each box diagonally, and make them a little bit longer on the edges. 3 times 1 is 3, 3 times 7 is 21, 0 times 1 is 0, and 0 times 7 is 0, so 0, 0. 5 times 1 is 5, and 5 times 7 is 35. Adding down the diagonals, we've got 1. 3 add 2 is 5. Adding down this one, I've just got 5. Adding down here, I've got 8, and that's 0. So 8,551. So same answer, but just a different way of doing it. Use whichever one you prefer, because it's completely up to you. 1 table costs £63. How much would 502 tables cost? So again, I'm going to do 502 times 63. And you can do this in either way. I'm just going to do it this way for this one. 3 times 2 is 6. 3 times 0 is 0. And 3 times 5 is 15. Then we're moving over to the 6 here. So put a 0 in here to hold the place value. 6 times 2 is 12, so 2 carry the 1. 6 times 0 is 0, add the 1 is 1. And 6 times 5 is 30. There we go. Adding that together, I've got 6, 2, 6, 1, 3. So it's going to be £31,626. It's a lot of money for a lot of tables. Cool. Let's move on to deepen. So the most difficult multiplying questions now. In the multiplication triangle below, the numbers in the circles multiply together to make the number in the rectangle in between. So this number here is by doing 24 times 76. It's the number at the top times the number at the bottom of that side. This one here is from doing 69 times 76. And so to get this answer, we need to do 24 times by 69. So let's do that in this method this time. Why not? Mix it up a bit. 24 times 69, split them all diagonally. 4 times 6 is 24, and 4 times 9 is 36. 2 times 6 is 12, and 2 times 9 is 18. Then adding down the diagonals, I've got 6. Adding down this one, I've got 4, add 3, add 8, and that's 15, carry the 1. 2, add 1 is 6, and we've just got a 1 there. So that would be 1,656. And you should get the same answer if you did it the other way, if you did 24 times 69 like that. Should get the same answer. Don't forget to put that 0 in when you move over to the 6. Lovely. In the number pyramid below, each number is calculated by multiplying the 2 numbers below it. Find the missing numbers. So we do 4 times 36 to get 144. We're going to do 4 times 4 to get this number here, so that's 16. And then to get the number at the top, we need to do 16 times 144. So I'm going to do 144 times by 16. 6 times 4 is 24. So 4, carry the 2. 6 times 4 is 24. Add the 2 is 26. And 6 times 1 is 6. Add the 2 is 8. Then I'm going to put that 0 in because I'm moving over to the 1 here now, but it's actually a 10. 1 times 4 is 4. 1 times 4 is 4. And 1 times 1 is 1. We've got 4. 6 add 4 is 10. 8 add 4 is 12. Add the 1 is 13. And 1 add 1 is 2. 2,304. Perfect. Question number 3. A plane ticket to Vienna costs £194. The table shows the number of plane tickets to Vienna sold each day last week. How much money was spent on tickets to Vienna on Tuesday? So 37 tickets were sold on Tuesday, and each ticket is £194. So we're going to do 194 times by 37. 7 times 4 is 28, so 8 carry the 2. 7 times 9 is 63, add the 2 is 65. And 7 times 1 is 7, add the 6 is 13. Putting that 0 in, 3 times 4 is 12, so 2 carry the 1. 3 times 9 is 27, add the 1 is 28. And 3 times 1 is 3, add the 2 is 5. So we've got 8, 7, 5 add 2, 3 add 8 is 11, carry the 1, and 1 add 5 is 6, add the 1 is 7. 7,178. Perfect. Work out 720 divided by 10. So we said in the previous section that when we times by 10, we move all the numbers one column to the left. So when we divide by 10, we're going to move them one column to the right. So remember that 720 is 7 hundreds, 2 tens and 0 ones. And we've got the decimal point here. So if we're dividing by 10, we're going to move all of those numbers one column to the right. So the 7 is going to end up in the tens column. The 2 is going to end up in the ones column, and the 0 is going to end up in the tenths column. But because it's 0.0, we actually don't need to include it. So our answer there is going to be 72. Similarly here, I've got 64.1, so let's just make this longer. 64.1. If I'm dividing by 10, again, I'm moving all of those digits one column to the right. So the 6 is going to end up in the ones column, the 4 is going to end up in the tenths column, and the 1 is going to end up in the hundredths column. So there, so 6.41. Question number 3, I have 21 coins. I want to arrange them into 3 equal groups. How many coins will be in this group? Each group, sorry. So we're doing 21 divided or shared into 3 equal groups, and using our times tables we know that 3 times 7 is 21, so 21 divided by 3 is 7. What is the remainder when 23 is divided by 4? So the 4 times table goes 4, 8, 12, 16, 20. The next number in the 4 times table is 24, so that's too big. Okay, so we've got 1, 2, 3, 4, 5, and we're trying to get up to 23. So it fits in 5 times, 4 fits in 5 times with a remainder of 3, because it fits in 5 times to get to 20, and we've got 3 left over to get up to 23. Okay, 65 divided by 5. So here we can see that it's been laid out in the bus stop method for us, or so short division you might know it as. 65 divided by 5. So we need to ask ourselves, how many 5s fit into 6? How many times can it fit in a whole number of times? Well, it only fits in once, and we have 1 left over, so that goes here. And then we look at this as being 15. So how many 5s fit into 15? Well, that would be 3. So our answer is 13. We're going to use the same method here to do 170 divided by 5. So how many 5s fit in to 1? Well, none. It doesn't fit in at all, and we haven't used that 1 up, so we're going to carry it over onto the 7, and that's now 17. How many 5s fit into 17 a whole number of times? Well, 5, 10, 15, that's 3 whole times. And because that was 15, we've got 2 left over. 5 into 20 goes 4 whole times. So our answer is 34. We're now going to strengthen, so work out the number that should go in the box to complete the calculation. Something divided by 10 is 0.3. So we're saying we've moved all the numbers one column over to the right. So if you think about your ones, your tens, your tenths, we've ended up with 0.3. So what did it look like? When we divide by 10, we move all the numbers one column over to the right. So let's move it back. The 3 is going to end up back in this column and the 0 in the tens column. But it doesn't really matter that the 0 is in the tens column because we would only write 3 anyway. We wouldn't write 0, 3. We don't need it before the 3. Good. 3 divided by 10 is 0.3. Divide 312 by 6. So again, we're going to use that bus stop method or short division, however you call it. 6 into 3. How many 6's fit into 3? Well, it doesn't. Not a whole number of times. So we can put 0, and we haven't used any of those 3 up, so we're going to make it, carry it over and make it 31. 6 into 31 goes 5 whole times with 1 left over, and 6 into 12 fits twice, so 52. 266 divided by 7. 7 fits into 2, no whole times, and we haven't used any of those 2 up, so let's carry them over. 7 into 26, so we've got 7, 14, 21, and then 28, which is too big. So it's going to fit in 3 whole times with 5 left over. And 7 into 56, hopefully you know that times table, it's one of the trickiest ones. 7 times 8 is 56, so 7 into 56 is 8. So we're left with an answer of 38. Question number 4. Anne has 144 to share between her 6 grandchildren for Christmas. If she divides it equally between them, how much does each grandchild receive? So we're going to do 144 divided by 6. How many 6's fit into 1? Well, that is 0 whole times, and that 1 needs to be carried over. 6 into 14 goes twice, remainder 2, and 6 into 24 goes 4 times, so £24 each. And for this bottom one, 288 divided by 12. Now, you've got a few different ways to do this. You can either do long division, or you can do the bus stop, same as before, short division, or we can do something called the double-decker bus stop. I'll show you that in a minute. So how many 12s fits into 2? Well, it doesn't. So we're going to put a 0 above and carry the 2 over. How many 12s fit into 28? Well, 12, 24, 36, so it fits in twice. But 24 up to 28 has 4 left over. How many 12s fit into 48? That fits in 4 times. So that's one way of doing it. Another way of doing it is to do something called the double-decker bus stop. So if you want to divide by 12, instead of dividing by 12, you can divide by 3 and then divide by 4. As long as these two numbers times together to make 12, it will still work. And you just might find that a little bit easier. So 288 divided by 3, and then take the answer and divide it by 4. So 3 into 2 doesn't go a whole number of times, carry the 2 over. 3 into 28 goes 9 times, because that's 27, with 1 left over. And 3 into 18 goes 6 times. Then 4 into 0 is 0. 4 into 9 fits 2 whole times, remainder 1. And 4 into 16 goes 4 times. So we still get the same answer, but you might just find that a little bit easier if you're more comfortable with your 3 times table and your 4 times table rather than your 12s. But equally, you could do divide by 2, divide by 6. That would work as well. So lots of options for you there. And then deepen the most difficult questions here. A group of 4 friends has a bag of 47 sweets. They divide them equally between them. How many do they get each and how many are left over? So with our 4 times table, we know we've got 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. So hopefully it makes sense if I say that they all get 11 each, because we haven't quite got enough to give them 12 each. That would be 48, and 44 sweets is needed to give them each of the friends the same number of sweets, to give them each 11 sweets. 44 is needed. We've got 47, so that is 3 sweets left over. 47 divided by 4 is 11, remainder 3. Question number 2. Bruce needs 26 burgers for a barbecue. They're sold in packs of 6. How many packs does he need to buy? So 26 divided by 6. How many 6's go into 2? It doesn't, so we're going to carry that 2 over. Oh, hasn't really helped us. So 6 into 26, we've got 6, 12, 18, 24, and then we've got 30. Cool. So 1, 2, 3, 4, 5. Now, this is only going to fit in 4 times, and then we've actually got a remainder. Now, to deal with that, we put 0.0, and we're going to carry what's left over. So 6 into 26 goes 4 times, remainder 2, and then that can be carried onto that. We put the point up here as well. 6 into 20 goes 3 times, and then we've still got a remainder. But at this point, it would be 4.3 recurring. I can't go into the shop and say, can I have 4.3 recurring packets, please? I'm going to have to buy extra, aren't I? So in this case, it's 4 with a remainder, 4.3 recurring in this case. We're going to have to buy 5 packets because 4 packets just isn't going to be enough. Question number 3, look at the 2 calculations below. Use the top calculation to find the missing number in the calculation below it. 300 divided by 12 is 25. So 300 divided by 12 is 25. 300 divided by what is 50? Now, if you notice, this is twice as big. It's twice as big. So if I've got 300, let's say this is my bar, 300, and I'm dividing it by 12 to get 25, if the answer is 50, that's double. So I've got 50 there, I've got 50 there, 50 there, 50 there, 50 there, and 50 there. So I haven't divided it by anywhere near as much, have I? In fact, I've actually divided it by half as much. There are now only 1, 2, 3, 4, 5, 6 piles. So we're going to say that this is 6. 300 divided by 6 would be 50. If we divide by half as much, then the answer would be double. Question number 4. 777 will divide by 37 with no remainder. What is the remainder when 775 is divided by 37? So if we know that when we do 777 divided by 37, it goes in exactly and there's no remainder, we've now got 775. Now that is just 2 less. So the remainder, it's going to go in less times, isn't it? It's not going to go in an exact number of times. It's going to go in 1 less time. And what's going to be left over is the difference. So it's actually going to be 35 that's left over, because that's how many on top. So if you've got a whole number of times and you're saying, right, I'm going to take 2 away, and now you've got less, the remainder would be that gap. So the remainder is going to be 35. We can't fit a whole nother 37 in because we've got 2 less. So now only 35 is available to us at the end, and that would be the remainder. Another tricky question there, so well done if you got that. Moving on to fractions. Which shape below is 2/5 shaded? So 2/5 is said 2/5, but we could also say 2 out of 5. So with each of these shapes, we've got 5 parts. 1, 2, 3, 4, 5. So we're looking for the shape that has 2 shaded out of 5. So in this case, that's going to be B. We've got 2 of them shaded out of 5 sections. So B. What fraction of this shape is shaded? For question 2, I've got 1, 2, 3, 4, 5, 6, 7, 8. And 4 of them are shaded. So 4 out of 8 is an absolutely acceptable answer, and we could put that in the answer line. But what I'm going to do is I'm going to simplify that fraction. Because they're both in the 4 times table, we can simplify by dividing by 4. So if I divide the numerator by 4, the top number, I get 1. And if I divide the denominator, the bottom number, by 4, I get 2. So you could have written 4 over 8 as your answer there. They didn't tell you to simplify it, so that's fine. We could also write a half. What is 2 out of 11 written as a fraction? So we're just quite simply going to put 2 out of 11. We can't simplify that fraction, so that's fine. They've not got any common factors, nothing we can divide them both by to give a whole number answer. Question number 4. The number line below is divided into 10 equal parts. Which letter shows the position of 3/10? So if you imagine 1 divided into 10 sections, can be written as a tenth. So we've got 1 here, and we've divided it into 10 sections. So this is 1/10, 2/10, 3/10, 4/10, 5/10, which simplifies to a half, 6/10, 7/10, 8/10 and 9/10, and then 10 out of 10, which is 1 whole. So which one is 3/10? Well, hopefully we can see that that is D. Great. Fractions 1 strengthen. So which two of the shapes are half shaded? Now C is definitely half shaded. We can see that there are 16 squares, so we're looking for 8 of them to be shaded in. 1, 2, 3, 4, 5, 6, 7, 8 out of 16. The other one that's half shaded is F. It is diagonal, but we can still see that half of it is shaded and half of it is unshaded, so C and F would be your answers there. Question number 2, what fraction of the flag shown below is shaded? Well, let's not count all these squares, let's be sensible. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes going across, and 1, 2, 3, 4, 5 rows. So 9 times 5 tells us that there are 45 squares here altogether. And of those, how many are shaded? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 out of 45 is how many are shaded. Question number 3, write down the two shapes that are divided into quarters. So we're looking for a quarter, we're looking for the exact same amount in each of the 4 sections. So if you look at A, for example, this is not divided into quarters because this bit here is way bigger than the other sections. We want the same amount in each of the sections. So B is going to be one of our answers because we've got 4 squares here, 4 squares here, 4 squares here, and 4 squares here. So that is one of the correct answers. The other one that's divided equally is F. You can see that we've chopped it in half and chopped it in half again. So each of these 4 sections is equal. So F is our other answer. Now, fractions 1 for deepen, so the hardest questions here. Write down the two shapes that are less than half shaded. Less than half shaded. So we want the coloured in bit to be smaller than a half. So 8 squares out of 16 is half. So we want to be smaller than 8 shaded. A does not have smaller than 8 shaded. B does have smaller than 8 shaded. We've got 1, 2, 3. These two would make another 4. And that would be 4.5. So B is one of our answers. C's got way more than half shaded. We've only got 3 unshaded there. D has got exactly half shaded, which isn't the same as less than half shaded. E's got half shaded, and F is another one where we've got less than half shaded. Half would be up to here, wouldn't it? So we would need that bit as well. So that's less than half. Cool. What fraction of £1 is 17p? So we know that a pound is the same as 100 pence. So 17p is 17 out of 100. It helps to have them in the same unit. So rather than having pounds and pennies, we've just got 17 pence out of 100 pence. What fraction of an hour is 23 minutes? So again, we've got 1 hour, but we've got 23 minutes. It's going to be much easier if they're in the same format. So 1 hour, we know, is 60 minutes. And 23 minutes. So as a fraction, 23 minutes out of 60. Question number 4. Which two of the shapes below are 3/4 shaded? So we want there to be 3 out of 4. Now it's worth noting that 3 over 4 is the same as 6 over 8. They are equivalent fractions. If we've doubled the top and doubled the bottom, or we could also say that's equivalent to 9 over 12 because we've multiplied the top by 3 and the bottom by 3. So we might be looking for it to be more than out of 4, but we can do that. So A has 1, 2, 3 shaded out of 1, 2, 3, 4, 5, 6, 7. Now that is not the same as 3/4. B has 1, 2, 3 shaded out of 1, 2, 3, 4, 5, 6. That's not the same as 3/4. C has 1, 2, 3, 4, 5, 6 shaded out of 8. And we can see that that is the same as 3/4. If you were to just look at 4, you could make it so these 3 are shaded out of those 4 and these 3 are shaded out of those 4. So C is definitely one of our answers. And then the other one is going to be E because I've got 3 shaded out of 4. F, you might think it is, but for F, this section is way bigger. And it's got to be all 4 sections equal to be able to do it as 3/4. So it was C and it was E. Okay, fractions 2. What's the missing number in these equivalent fractions? So we said before that what we do to the bottom, we need to do it to the top. So if we've multiplied the bottom, the denominator, by 4, we also need to multiply the numerator by 4, and that becomes 8. So that's then an equivalent fraction. To simplify, we need to find the biggest number that goes into both as a factor. So the biggest factor of 2 and 10 is 2. If we divide the numerator by 2, we get 1, and if we divide the denominator by 2, we get 5. So that's 1 over 5. Question number 3. What fraction of the shape below is shaded? We've got 1, 2, 3, 4, 5, 6, 7, 8 shaded out of 10 squares altogether, and we can simplify that because they're both in the 2 times table. So dividing by 2, we get 4 over 5. There we go. Put these fractions into ascending order, smallest to largest. So ascending, again, we're seeing that word, it means going up. We've got to put the smallest one first. Now this is okay because all the denominators, the bottom numbers are the same. We can just go straight ahead and compare the tops. So the smallest, if we imagine a bar with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. If we had 2 out of 10, that would be the smallest amount shaded in. Then 3 out of 10 would be a bit bigger. And then 7 out of 10 would look like that. So that would be the biggest or the most amount shaded in. Okay, strengthen. Put these fractions in ascending order, smallest to largest. Now this is harder because our denominators, our numbers on the bottom of the fraction are different. So we've got 3/4, 1/4 and 5 out of 8. Now we would ideally like all of those denominators, bottom numbers, to be the same. And we can do that quite easily by making the denominators that are 4 into an 8, and then they'll all be 8. As long as, if we're timesing the bottom by 2 to get 8, we also times the top by 2. So I'm going to change these to be 5 over 8 can stay 5 over 8, but 1 over 4 can become 2 over 8. I've doubled the bottom, so I've had to double the top to keep it equivalent. And here as well, I've got 6 over 8. I've doubled the bottom, so I need to double the top. And now they're all out of 8, it's a lot easier to see that 2 over 8 is the smallest, which is the same as 1/4. And then 5 over 8 is the next smallest, and that was 5 over 8 originally. And then 6 over 8 is the biggest, which was given to us as 3/4. If you wrote your answer as 2 over 8 and then 5 over 8 and then 6 over 8, that's absolutely fine as well. I just prefer to put them back in the format that they gave them to us in, just so it's nice and clear. Okay, question number 2. Which 2 shapes are 3/4 shaded? So A is 1 shaded out of 4. B is 3 shaded out of 4. So great, we want that one. C is 3 shaded out of 7. That's no good. D is 1, 2, 3, 4, 5, 6 shaded out of 8. E is 2 shaded out of 8. And F is 1, 2, 3, 4 shaded out of 7. So of those, we know that 3/4 is fine. And we know that 3/4 is equivalent to 6 over 8 because we've times the top by 2 and we've times the bottom by 2. So B is the other acceptable answer there. So B and D would be our correct answers. Question number 3. Use 2 of the cards below to make a fraction that is equivalent to 16 over 20. So we know that as long as we do the same to the top and the same to the bottom, then it's an equivalent fraction. So I'm looking for a times table that they're both in, and they're both in the 4 times table. If we divide the top by 4 and we divide the bottom by 4, we get 4 over 5. And great, we've got that there, that we can use a 4 for the numerator and a 5 for the denominator and get an equivalent fraction. We could also have done 8 over 10, because if we times that by 2 and times the bottom by 2, but we had 10 and we didn't have 8, so that would be no good. Another one would be 12 over 15, if we times this by 3 and times the denominator by 3, but we didn't have either of those. So there are different answers, but in this case we had to have both the numbers, so it makes sense to make it 4 over 5. Complete this equality to find 3 equivalent fractions. So if we've made the numerator 3, we've times the numerator by 3, then we also have to times the denominator by 3, and that leaves us with 12. If we've made the denominator 20, then we've times by 5 from this number. So we also need to times the numerator by 5, and that is 5. And all of those are equivalent. Fractions to deepen, so these are the most challenging ones. Hamza makes a cake and cuts it into 16 equally sized pieces. He gives 12 pieces to Jack. What fraction of the cake does Hamza have left? Give your answer in its simplest form. So if she had 16 pieces and she's given 12 of them away, then she's left with 4 pieces. 4 pieces out of 16. Now that fraction can be simplified because they're both in the 4 times table. So the numerator's in the 4 times table and the denominator's in the 4 times table. So dividing by 4, we're left with 1 over 4, so a quarter. Question number 2. Jan says that the same fraction of each rectangle below has been shaded. Is Jan correct? Write a sentence to explain your answer. So for the first shape, we've got 2 shaded out of 6. And for the second, we've got 1, 2, 3, 4 shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, are those two fractions equivalent? Let's simplify them both and see. So 4 over 12, both in the 4 times table. So let's simplify that by dividing by 4. That becomes 1 over 3. And with the fraction over here, they're both in the 2 times table. So let's divide by 2, and that's also 1 over 3. So yes, she is correct. Both have 1/3 shaded. Great. Both fractions simplify to 1/3. Question number 3. What fraction is exactly halfway between 4/5 and 14 out of 15? Now this is really tricky to do because the fractions have different denominators. So we can see that this one has a denominator of 5 and this one has a denominator of 15. It would be easier if those denominators were the same. So I'm going to keep 14 out of 15, but I'm going to change this fraction to also be out of 15. Now, if I've made the denominator 15, I've multiplied it by 3, I also need to times the numerator by 3 to keep it equivalent, and that is 12 out of 15. Now, it's a lot easier for us to see what's halfway in between. Halfway in between 12 out of 15 and 14 out of 15 would be getting 13 out of 15. So making the denominators the same makes it much easier to compare and to see how the numbers sit. Okay, on to prime numbers and factors. Work out all the factors of 10 by completing the factor pairs below. So 10 can be written as 1 times 10. So 1 and 10 are therefore factors of 10. They fit in an exact number of times. But 10 can also be written 2 times 5. So the factors of 10 are 1, 2, 5 and 10. They all fit into 10 an exact whole number of times. Question number 2, work out all the factors of 14. Well, we have 1 and we have 14. We also have 2 that fits in an exact number of times. It fits in 7 times. 3 doesn't go in, 4 doesn't go in, 5 doesn't go in, 6 doesn't go in, and then we've already got 7. So all the factors of 14 are 1, 2, 7 and 14. Question number 3, which two numbers complete the following sentence? 7 is a prime number because it only has 2 distinct factors, which are 1 and 7. So there's only 2 factors of 7. 1 in itself, so 1 and 7 are 2 distinct factors. For each number, decide whether it's prime or not. So 5 is a prime number because the only 2 factors of 5 are 1 and 5. So that's prime. 1 is not a prime number because its only factor is 1. And to be prime, it has to have 2 different factors. 8 is not a prime number because it has factors of 1, 2, 4 and 8. So that's not a factor. So not prime and not prime. Great. Question number 5, find all the prime numbers from the list. So we're looking for numbers that are only in the 1 times table and their own times table. So 11 is prime because it's only in the 1 times table and the 11 times table. 18 is not prime because it's in the 2 times table. 1 is only in the 1 times table, so that's not prime. It's got to be in the 1 times table and its own times table, and that can't be the same. 17 is prime. It's only in the 17 and the 1 times table. 21 isn't, because we can say it's in the 3 times table or the 7 times table, and same with 14. 14 is not prime because it's in the 2 times table and the 7 times table. So the answer is 11 and 17. They're the only 2 prime numbers in that list. Write out all of the prime numbers between 0 and 10. 1 we've said is not a prime number because it is in the 1 times table, but that's it. It only has one factor. 2 is prime, 3 is prime, 5 is prime, 7 is prime, and some people think that 9 is prime, but if we think because it's in the 3 times table, it's not. So 2, 3, 5 and 7. Which number in the list below is not prime? So prime numbers are only in the 1 times table and their own times table. If there are other factors or other times tables that they're in, then they won't be prime. So 15, we can see, is in the 3 times table and the 5 times table. So we've got 1, 3, 5 and 15 that are factors of 15. So that's not prime, 15. All the other numbers are only in their own times table and the 1 times table. For question number 2, find all the factors of 20. We've got 1 and 20, and we've also got 2 and 10, and we've also got 4 and 5. So it's helpful to find factors in pairs because they're always going to work in pairs, and then we can write them in order afterwards. So 1, 2, 4, 5, 10 and 20. Question number 3, which 3 of the numbers below are factors of 100? So factors are going to fit in an exact number of times. So 2 is a factor of 100. 9 is not a factor of 100, it doesn't fit in an exact number of times. 10 is a factor because it fits in 10 whole times. 25 is a factor because it fits in 4 whole times. 35 does not fit in an exact number of times, and 200 can't be a factor because it's bigger. So 200 is actually a multiple of 100, but it isn't a factor, it doesn't fit in an exact whole number of times. Question number 4, how many factors does 40 have? So we have 1 and 40, 2 and 20, 3 does not go in, but 4 goes in 10 times, 5 goes in 8 times, 6 doesn't fit in, and 7 doesn't fit in. So that's it, we're done. 1, 2, 3, 4, 5, 6, 7, 8 factors. Okay, now to deepen the hardest questions. For each number, decide whether it's prime or not. So 51, I know that 51 is not prime. I know it's in the 3 times table. The reason I know it's in the 3 times table is because if you do 5 add 1, and you get 6. If you add together the digits and the number that you get is in the 3 times table, then the original number is also divisible by 3. Let's just check that. 51 divided by 3. 3 into 5 goes once, remainder 2, and 3 into 21 goes 7 times. So yeah, we can see that 51 is 3 times 17, so that is not prime. It's in the 3 times table and the 17 times table. 87, now let's use our trick. 8 add 7 is 15. So that's in the 3 times table. This also must divide by 3. Let's check. 87 divided by 3. 3 into 8 goes twice, remainder 2. And 3 into 27 goes 9 times. So it's 3 times 29. So that is not prime. Now, 59 is not in any times table that I can think of, and if we do 9 add 5 we get 14, so it's not in the 3 times table, it's not in the 4 times table or the 5 times table or 6 or 7 or 8 or 9 or 10 or 11 or 12. So by working our way up we can see that that isn't in any times tables, so it's only in the 1 times table and the 59 times table, and that means that it is prime. What is the largest 2-digit prime number? Now, I happen to know this one. So if we're working backwards from 100, the biggest 2-digit number is 99, and then 98 and 97. Now, 99 is in the 11 times table, so that's no good, that's not prime. 98 is in the 2 times table, that's no good. 97 is in fact a prime number. It's not in any times table other than 1 and 97. So 97 is our biggest 2-digit prime number. So it's just a case of thinking about what times tables it could be in. That's quite a tricky one if you don't just know it. So have a play around with the numbers and see what you can get there. Question number 3, find 2 primes which add to make 28. What is the difference of these 2 primes? So let's write out our first few prime numbers. We've got 2, 3, 5, 7, not 9, 11, 13, 15 isn't prime because it's in the 3 and the 5 times table. Then we've got 17, 19, 23 and so on. So looking at those, we want 2 of those that make 28. And I can see that we can use 23 and we can use 5. Those two would add together to make 28. So 23 add 5. It says what is the difference of these two primes? So difference means we need to subtract. So 23 take away 5 is 18. What is the area of this rectangle? So for area, we can either count the squares, or if we don't have the squares, for a rectangle, we can do base times height. So either by counting the squares here, or by doing 2 times 4, we get an answer of 8 centimetres squared. What is the perimeter of this triangle? Perimeter is the distance all the way around the outside of a shape. So we're going to do 5, add 6, add 3. 5 add 6 is 11, add the 3 is 14 centimetres. What is the area of this rectangle? So area is that space inside, and again we're going to do base times height. So 6 times 2 is 12 centimetres squared. What's the perimeter of this rectangle? Perimeter is the distance around the outside. So we need to do 7, add 3, add 7 for the bottom side, add 3. We've got to go all the way around the outside. 7 add 3, add 7, add 3 is 20 centimetres. What is the area of this rectangle? So now we're doing 9 times 7, base times height, which is 63 centimetres squared. Work out the area and perimeter of this rectangle. So the area of this blue rectangle is the space inside it, and to get that we do 6 times 2, which is 12 centimetres squared. The perimeter is the distance around the outside. So 6 add 2, add 6, add 2, because we also need to do the top side and the left side, and that is 16 centimetres. The area of this square, again, it's a bit like a rectangle in that we need to do 3 times 3, base times height. We know it's 3 across here, and it's 3 going up here. So base times height, the area inside the shape is 3 times 3, which is 9. I knew it was 3 going up because it's a square, so we know it's the same length in all directions. Calculate the perimeter of this pentagon. Now, because it's regular, that means that all of the sides are the same length. So we can do 4, add 4, add 4, add 4, add 4, or 4 times 5, which is 20 centimetres, is the distance all the way around the outside of the shape. Question number 1, work out the perimeter of this shape. So the perimeter, as we know, is the distance around the outside. I need all of the lengths of all of the sides, and I need to go all the way round. This side up here isn't labelled, but let's see if we can work it out. I know that this side here is 4, and I know that this bit here is 2. So altogether, if we add those, we can see that this would be 6 up here. So we're going to do 5, add 2, add 3, add 4, add 2, add 6, which is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, add another 6 is 22 centimetres. For question number 2, what is the length of the unknown side? So we know that area is base times height, or length times width. So we need to know what number here would multiply by 3 to get 12. So something times 3 equals 12. And we can get our answer by doing 12 divided by 3, and hopefully you can spot that that needed to be a length of 4. Question number 3, what is the length of one side of this regular pentagon? So the perimeter is 15, so that means something, and I'm going to use an X because I don't know what it is. Add something, add something, add something, add something equals 15. Now they all have to be the same number. So X, add X, add X, add X, add X equals 15. So we know they're all the same, so we could just do 15 divided by 5. And that is 3, and that makes sense. 3, add 3, add 3, add 3, add 3 is 15. So each side is 3, and that gives a perimeter of 15. A rectangle has an area of 24 centimetres squared. How long could the sides of the rectangle be? So if we have a rectangle that is 24, we need a base times a height, or a length times a width, that's going to multiply together to make 24, because we know that to find the area of a rectangle, it's base times height, or length times width. So we just need 3 different pairs of numbers that multiply to make 24. So that could be 12 by 2. So it could be 12 centimetres by 2 centimetres. Or it could be 8 centimetres by 3 centimetres. Or it could be 6 centimetres by 4 centimetres. And there are some other ones, but as long as they multiply together, the two numbers, to make 24, then that would give an area of 24, and that would be a correct answer. You could also have 1 centimetre by 24 centimetres, and so on. One minibus can seat 8 passengers. How many passengers can be seated on 6 identical buses? Or I should say many. How many passengers can be seated on 6 identical minibuses? So if we've got one bus fitting 8 people on it, then we can do 8 on this bus, 8 on this bus, 8 on this bus, 8 on this bus, 8 here and 8 here. So 1, 2, 3, 4, 5, 6 lots of 8. That means we can fit 48 passengers on the buses. Question number 2. A recipe to serve 4 people uses 200 grams of flour. How much flour is needed to make the same recipe to serve 8 people? So if we have twice as many people, we're going to need to multiply our recipe by 2 as well. So we're going to do 4 people times 2 equals 8 people. So then we also need to do 200 grams of flour times 2, which is 400 grams. Question number 3. Asher buys 6 identical sweets that cost 18p in total. How much does one of the sweets cost? So to get the cost of one sweet, we need to do 18 pence divided by the 6 sweets. And 18 divided by 6 is 3. So each of these sweets cost 3 pence. So one sweet, just 3 pence. For the strengthen questions, Imran is making fairy cakes using the recipe below. How much flour is needed to make 20 fairy cakes? So this makes 10 cakes. For 20 cakes, we're going to need to double our recipe. So instead of 2 eggs, we're going to need 4 eggs. Instead of 120 grams of flour, we're going to need 240 grams of flour. We're going to need 200 grams of sugar, because we've times that by 2 as well. 160 grams of butter. And instead of half a teaspoon, we're going to have 1 whole teaspoon. So we've doubled that as well. How much flour is needed? So the only bit we need is this bit, 240 grams of flour. Johanna is baking chocolate biscuits. The recipe she is following uses 150 grams of sugar and makes 30 biscuits. If Johanna only has 50 grams of sugar, then how many biscuits can we make? So 150 grams makes 30 biscuits. We only have 50 grams of sugar. So what have we done to this side? Well, we've divided it by 3. And if we've divided that side by 3, we're going to need to divide the recipe by 3 as well. So it will only make 10 biscuits. Question number 3. Indy makes some strawberry muffins following the recipe provided. If Indy uses 550 grams of flour, how many grams of strawberries must she use? So 110 grams is how much flour was used before, and we're now using 550 grams of flour. And we can see if we do 550 divided by 110, or we multiply that up, it's 5 times bigger. So if we've multiplied that by 5, we need to also multiply the strawberries by 5, or else our recipe might not be as good. So we're going to multiply this by 5 as well, and that is 250 grams of strawberries. And last page, ratio relationships for deepen, so the harder questions. Alice buys 10 identical toy boats and spends £80 in total. How much would 7 toy boats cost? So if 10 toys is £80, then 1 toy we're going to divide by 10. Now we looked at dividing by 10 earlier in the pack, and dividing by 10 moves all the numbers one place to the right, so we get £8 in the ones column rather than in the tens column. So if 1 toy is £8, then 7 toys, we're going to multiply by 7, and that would be £56. Finn is stacking identical cube-shaped boxes. He stacks 7 boxes to make a tower that is 112 centimetres tall. He adds 1 more box to the tower. How tall is it now? So we've got 7 boxes. 1, 2, 3, 4, 5, 6, 7, and that's making a height of 112. So if we do 112 and we divide that by 7, we'll find out the height of each box. 7 into 1 doesn't go, carry the 1. 7 into 11 fits once, remainder 4, and 7 into 42 goes 6 times. So we now know that each of these boxes has a height of 16. So we know that 16, 16, 16, 16, all the way up. And if we add an extra box on the top, then that's also going to have a height of 16. So 112, add on the extra 16 for the 8th box, is 128. Question number 3. Mia wants to predict how many times her heart will beat in an hour. When she is resting, her heart beats 5 times in 6 seconds. Use this information to predict the number of times her heart will beat in 1 minute. 5 beats, or 5 times, equals 6 seconds. A minute is 60 seconds. So what have we done to the right-hand side of our equation? We've multiplied it by 10. So we also need to multiply the left-hand side by 10, and that would be 50 times. So we could expect it to be 50 times in 60 seconds. And then it says, what about in an hour? So we know that an hour is 60 minutes. So in 1 minute, we said it did it 50 times. So then we want 60 minutes. So to get that, we're going to times by 60. So we need to do 50 times 60. And the easiest way to do that is to do 5 times 6, which is 30. And then make it 10 times bigger and another 10 times bigger for each of the zeros. So 3,000 would be my answer there. Amazing. Well done. You've reached the end of the pack. I hope you enjoyed it. And looking forward to you all starting school in September.